Hey everyone. Just before we start the webinar officially, I just want to share one or two housekeeping items. So first of all, you can see this webinar is recorded. So the recording will be shared with you after the webinar. We highly encourage to make it dynamic session. So you have a Q&A button at the bottom. Feel free to ask questions throughout the presentation. I will read through them and ask Abdul throughout the presentation. Before starting, just a quick introduction. So my name is Alexandre Gerbeau. I am the regional vice president of a team called the Apply AI Expert Team for DataRobot in APAC. So I essentially lead the technical team for the region. My job and my team's job is to make sure our customers at DataRobot realize value, leveraging our technology. I'm based out of Singapore, Abdul in Australia. I've been in the business for 6 years. I focus on FSI, and this is why I'm super excited to talk about this topic today and have Abdul joining me. He's going to share very interesting stuff. Abdul, don't you introduce yourself before we jump into the agenda?
Thank you, Alex. Hello, everyone. This is Abdul. I'm part of Evolve AI Labs. I lead the engineering team there. Currently, the director of AI products. About me, I have around 17 years of experience around data. A couple of patents in AI and ML as well. So yeah, at Evolve AI Labs, we kind of like help accelerate our customers on their AI journey.
You can see Abdul has a very sleek photo. It looks great on the slide. If you're interested, he can share with you the actual Gen AI app that he used to make this, but looks very beautiful. Shall we go into the agenda? Okay. So we structured this webinar into 5 parts. First of all, we'll introduce quickly what DataRobot is and Evolve AI is. I understand there might be people in the audience that might be aware of those 2 companies. We just want to level set quickly. And then Abdul will start into the meat of the presentation because it's in the space of financial automation. We thought it would be good to also reintroduce you what financial automation is. And then we'll drill down into the use case, which is a payment reconciliation use case. So Abdul will share about some of the challenge that this customer has faced and how he used generative AI to address those challenges. And I think the most exciting part to me is the best practice and the key learning that Abdul will share back to you guys into his journey of learning, also different approach for this solution. So I think there's lots of interesting stuff there. First of all, just a quick intro about DataRobot. So about DataRobot, we are essentially a pure play AI and machine learning platform. We focus both on generative AI and predictive AI. We have been in the business for 12 years now. We have done a lot of use cases across the machine learning space and the generative AI space. So we really harden our platform to real world value. My team also developed an expertise throughout the years on a lot of different use cases that we have done with our customers. I think 3 facts for you to think about how impactful DataRobot is. About a third of our US foreign exchange goes through DataRobot. So we do have a very high quality and highly secure solution within the financial services. In APAC, we are working very closely with Gcash, where we are helping them to democratize financial services within their customer base. And in Australia, for example, we are working with hospitals to help them deliver better patient outcome. So before giving you a high-level view of DataRobot, and then throughout the presentation, we'll share with you a bit more about the technology and some of the latest features that were used by Abdul in this solution. And Abdul, if you can go to the next slide, I think what's very critical about this webinar is Evolve AI. So Evolve AI is our certified partner with DataRobot. It's a team of expert data scientists, engineer, and researcher that really focus on the end-to-end pipeline of use case. So they cover both identifying the use case, building pipeline, doing model building, and embedding those models into critical business decisions. So it's Evolve is the key partner of DataRobot, and then that's why I'm very excited to share that webinar with Abdul today. Abdul, yeah, you want to share a bit more about what you guys do?
Yeah, thanks, Alex. So at Evolve, we provide peripheral AI and ML services on top of DataRobot development and solutions. So as you can see here, Evolve provides AI strategy, data engineering and pipelines, model building in DataRobot, integration of DataRobot models into business systems and decision systems, and then anything related to change management in terms of like retraining the models, refreshing the models, and what have you. So that's all the additional stuff that we provide on top of DataRobot. Yeah, I think we can jump into the meat of the presentation today. So what is the main problem that a lot of financial teams are facing right now? One of the key you could say sinkholes in financial teams workloads is manual processing. So manual processes take up a lot of time. CFOs, at least 76% of CFOs of in a survey mentioned that manual processes take up significant chunk of their team's time and effort. Manual processes, even though they are effective, there are a lot of challenges with them, not only just cost and time. 56% of financial firms with large teams also reported the same. They still manually reconcile bank statements. Again, manually reconciling financial statements takes up a significant chunk of cost and effort for these firms. So how do we solve this? So basically, we are looking at financial process automation in a way to solve and mitigate the losses in cost and effort for these firms. What is financial process automation? Financial process automation is using technology to execute financial processes by minimizing the amount of human intervention required. Which areas are conducive and suitable for financial process automation? Accounts payable and receivable. So KYC, creation of new accounts, approvals, and deactivations of accounts, loan approvals, and all of that. Payroll and expense management, employee payroll, expense management to said employees and all of that. Account and payment reconciliation, which we are going to talk about today, is basically allocating payments across different accounts and entities. Billing, invoice, and order processing. So generating of billing, invoicing, approval of payments, and all of that. Then we have taxation and compliance, which deals with all the taxation aggregation, then compliance approvals, and all of that. So these are some of the areas which see a lot of opening or opportunity for financial process automation. But what are the advantages that financial automation brings? Definitely improving the efficiency in the process, reducing the costs and error rate, improving compliance, visibility, and decision making. So manual processing manual processing brings a bit of subjectiveness into decision making, but with automation, decision making becomes objective and consistent. It also improves scalability because once you automate a process, manual processes tend to hit the glass ceiling when it comes to scalability. You can only throw as many human agents at a process, but scalability suffers after a limit. So risk mitigation is improved because, again, lower error rate, so lower risk, and then customer and employee satisfaction is a intangible benefit that you get in terms of like once you automate a process because of all the other things in terms of like cost and error rates and visibility, these satisfaction, employee and customer satisfaction automatically increases. But although there are so many advantages, financial automation is hard. Even with machine learning models, it is very hard because of a variety of reasons. Some of the reasons, legacy systems, fintech firms have a lot of legacy systems. Just an example, all the transactions in the world pass through 5 gateways: Master, Visa, and 3 other. So legacy systems have been there for decades now, and they're not going away. So the outputs and the inputs to the systems for financial automation come from these legacy systems, and they are old. Complexity of processes and products. So even a single transaction that we do with our credit card, there are so many entities involved in terms of like approvals, transfer of funds, transfer of credits, and then approvals required. So the complexity of these products and processes in finance is quite high. Variety of instruments and processes. So for example, payroll processing, even though every company has payroll processing, every company has its own quirks and process that they follow. High accuracy requirements. Precision of the model is quite important. Even cents of a dollar over time make up millions. Complex regulatory environment. So you have FATCA, IFRS. These are regulations that you need to follow, which also hamper automation, because there is always manual intervention required in these kind of compliances. Finally, data security and privacy. Data standards like GDPR and portability of data not leaving the country's borders. And because it is financial, it is definitely uh, quite important that you take care of data security and privacy. This also limits the amount of training data that is available in public for machine learning models. So a lot of financial automation is hard because you don't have models that are readily available that are trained on these data, which is kind of like very limited to each organization.
Do you feel there is a typical organization profile where those challenges are even bigger than the other? I think you mentioned about legacy system. Like, do you
Yeah.
have an opinion on?
Yeah,
Yeah, but
definitely. So big banks,
yeah.
federal financial entities, these are places where you have legacy systems, you have a lot of data security requirements in terms of like the solution should run on their environments and within their infrastructure. So yeah, definitely that is where we see a huge challenge for financial automation.
Hmm, interesting.
Yeah. So quickly looking at the evolution of automation, because we want to understand how automation came into being and what is in right now. So in the 60s, automation involved mechanization and office automation through your mainframes. So automation was majorly aggregation and summation of data. So that earlier aggregation was done by humans and manual processes, but with mainframes, thousands and hundred thousands of records would be uh, summarized and automated. Summarization and aggregation would be automated. Coming to the 80s, we saw a lot of business software applications which came about and added a layer on top of summarization and aggregation. And this layer was management of data and very basic approvals and workflows. By the time 90s came in, the whole automation process took a new turn, which is the automation was implemented through workflows and process engineering. Processes were frameworks like ITIL, business process modeling, came into being, which kind of like set standards for business processes, which allowed the process to be split into gates and flows, and then thereby allowing more automation. In the early 2000s, with the advent of stronger programming languages and business logic, uh, robotic process automation came into being. This is where uh, people were able to scrape data from the internet, build workflows and decision flows, although not intricate decision making, but if then else logic was able to kind of like build basic workflows for automation. And the 2000 in the previous decade, predictive machine learning models really took over a lot of automation. The models that would classify, forecast use regression to kind of like predict data, and then you could use the models and the explanations that the models gave into automation. Then currently, with the large language models and the advent of models that can do human level reasoning at some tasks, generative process automation is something that is gaining rapid exposure. So we are using LLMs to kind of like take decisions and do complicated flows using LLM models. Generative AI automation is not just limited to financial automation, and Alex would be able to tell how different customers of DataRobot from different lines of business are able to implement generative AI automation using DataRobot.
Yeah, good point, Abdul. So this presentation is really focused on financial automation, but obviously we see generative AI across industries. I think what's interesting is the use case that Abdul is going to share with you is actually applicable to, like we see it in healthcare and HR as well, where they also have a challenge of reconciling records across different sources. And also another common use case pattern, and when you are trying to extract information from unstructured data to structured data. So we see that in legal when they are trying to find clauses into a lot of different documents, and it's very hard to manually review that one by one. So generative AI is a very good tool to address this. I think probably the most interesting part is on more the federal slash banking side with anti-money laundering use case, where we see generative AI not being used by itself, but complementing predictive AI, machine learning. So for banks, what they care about for anti-money laundering process is they want to be able to raise case for the investigator to review, like suspicious case. And typically this solution will use a machine learning model that will score a case and raise a flag if it's highly suspicious. But then generative AI can help to explain why the machine learning algorithm pick that flag and explain it in a very readable term. So solution using both predictive AI and generative AI to improve the adoption of the predictions. This is something we see in anti-money laundering, but also very, very common across industries. So yeah, good point, Abdul. We can see that also in other industries.
Thanks, Alex. Yeah, so before we look into the use case and the solution, we would probably have to take a step back to understand the business that we are targeting. So one of DataRobot's customers, a leading lender, uses or provides invoice financing as one of their products to the industry. And what is invoice financing, also known as data financing? So imagine a company like Evolve AI, which is a partner for DataRobot. And DataRobot, as a large organization, global organization, has hundreds of such partners across the globe. So every first of the month, Evolve would send an invoice to DataRobot. And because DataRobot is a large organization, they have their own pay cycles or disbursement cycles, which would be towards, let's say, 25th of the month. That is when their whole process run, and then they pay the invoice on that day. So the company would have to wait for 25 days for their invoice to be paid. In the meantime, what the company could do is they could go to a lender or a financier. They could sell this invoice, and the financier will pay them 80% of the invoice upfront. So what this does for the company is opens up a line of revenue quite early in the cycle, so that they don't have to wait for the pay cycle of the customer. The financier, what they do is they take over all the hassle of working with the customer and getting the payment ready for the company. And once the customer at the 25th of the month, they make the payment, the financier will then take their own fee or a percentage of the transaction and pay the remainder to the company. So what is the advantage for the customer or an organization like DataRobot? It simplifies their process. Instead of them having to individually allocate funds to each and every company to different accounts through different payment gateways, they can just push that or simplify their process by making one single payment of, let's say, $1 million to the financier, and the financier will take care of all the headache of allocation. So if you look at it, it's a win-win for everyone. So the company gets access to funds early, the financier earns a fee, and then the customer simplifies their process. So that is invoice financing in a nutshell. And this is this is the product for which this solution was built using DataRobot and generative AI. Coming to the problem statement, so this financier or lender was spending significant costs on manual allocations of funds and processing of invoices. So they had a team of manual agents that would sit and look at the emails, invoices, bank ledgers, and then allocate data. So for example, the whole process, just trying to put it in layman terms, you have a bunch of invoices and emails coming from the customer saying that these are the invoices for which they have made a bulk payment. And then the ledgers from different banks coming in. So the manual processing or the personnel would look at all of these invoices, correlate whether the payments were done, and then they would go into a back office application. In the application, you will have details related to the companies. So now they would split these transactions in the ledgers and allocate funds accordingly, which would then open the line of credit for the companies. So all of this process is manual. So 30% of the transactions were automated using SQL stored procedures, and these are straightforward, simple transactions, which are like one-to-one, one company to one customer to one invoice and one line item to pay. But the rest of the 70% are complex in terms of, like, there would be companies which would have multiple line items within the invoice, and they would make one payment for multiple invoices, versus there are companies which would split one invoice into multiple payments. So there is like a complex many-to-many relationship across, which takes at least a minimum of 20 minutes for certain invoices and emails to be processed. And they have like around 2,000 emails that they have to process, which is like a huge chunk, because of which they had a large team doing this manually. Coming to the objectives of the solution is supposed to automate all pre-authorized and straight-through payments. What pre-authorized means is below a certain value. So only payments which go into millions are something that are not pre-authorized and need special approvals, but rest of the transactions or invoices are pre-authorized. Deadline was yesterday when we spoke to them. So they don't have time to train and label new models. They wanted something to be done quickly because they were already spending a lot of cost and time on this. When DataRobot and Evolve spoke to them, we understood that they needed zero-shot learning, so something that is readily available. But when we looked at models on Hugging Face, the problem was they were trained on generic financial data, but the data that we needed to process all the invoices were something that the model was not trained on. So that's one of the constraints that we had, which is where we understood that generative AI or LLM models are good for this use case, because they are great zero-shot learning models. Coming to the outcomes that were expected, improve the automated match rate to 75% or more of the transactions, so which is currently at 30. They wanted like an uplift of more than 45%. Reduce the processing time. Just because we automated it doesn't mean that we take longer than a human agent or a human personnel. So we had to cut down on the processing time as well. So then the other expectation was provide customers access to funds faster. This is like a byproduct of the earlier expectation. And then overall reducing the workload on the human agents that are processing. So more automation, meaning fewer agents need to work on this, and they can be used for doing other important work.
I like the point you made here on the fact that there are no time to train the label. Like before, the machine learning approach would require you to label the data. So you are trying to address a cost-intensive task by asking another very intensive task, and then you saw generative AI being a great tool here because you have that zero-shot learning. I think one question I had is the 75%. Is this like something you like? Did you ask them to provide some example, and then you try and then got a good like feeling that was an achievable target? Was it how did you agree on that 75%?
Yeah. So 75% was a mix of two things. So one, ideally they looked at what is the sweet spot for them in terms of cost and the pre-authorized pre-authorized transactions. The second one was they also asked us to, and when we started off, the number was like a bit lower than this, but as we did the POC, we ran a few smaller data set through the LLM. We were able to kind of like get the accuracy or a match rate from our POC, and that kind of like rolled up into this as well.
Okay.
So just looking at the solution on a very high level. So there were two parts. One was the DataRobot piece, and the other one was the Azure piece. So what we were doing with this generative AI solution is basically we understood that at the crux of the problem, we needed an entity extraction and resolution engine. Entity extraction to look at all the emails, invoices, and extract the key financial entities like company name, customer, invoice numbers, the amounts in the line items. And then the second was the resolution or the mapping engine, which will take this information and then match it to structured data like tables and transaction records and the company company names and lookups. So very high level, we had to in the DataRobot piece of the solution has to ingest email and invoice, then extract data from this. So sort of like OCR from the PDFs. Then once we have the text, send it to an LLM. Use prompt engineering to extract data from unstructured data and convert it into structured data. In our case, from text to JSON, because JSON is a very good format for Python processing and universal format. Then use this information. Once we have the JSON object notation, we kind of like then go into matching this across the tables. We were using text similarity algorithms to do this because again, we were, even though the data is structured, the company names, again, are unstructured data that you need to match it. Once we have this match, we have to finally create golden record for each of the transaction, which will map invoice, and then it will map the transaction from the ledger, and then it will also then map it to the appropriate company to which it needs to be allocated. So once this golden record is available, this is fed into an accounts receivable app, which will then open up the line of credit for the company. The other piece or the Azure piece related to orchestration was built by the customer themselves. So or the lender. So what they used was because they were an Azure shop, they were using Azure functions for all the orchestration and pipelines. So this orchestration is basically every morning triggering the DataRobot process to run the whole process and then wait for the output at the end of the process. The second piece, they used Azure Functions first was to extract information from the inboxes where the emails would come in and the invoices would come in, extract data from the SQL warehouses, data warehouses, so that we have data from the bank ledgers and the back office application, and put them into Azure Blob Storage for DataRobot to pick in. So DataRobot has great integration with different sources. So here we were able to easily integrate with Azure Blob Storage and then pick up data from there. Then the final part, which is the LLM deployment, they wanted to use their own Azure OpenAI deployments that they had. So we used GPT that was hosted on Azure. And then we used DataRobot to kind of like monitor and use that LLM inside of DataRobot. So we use DataRobot because it's a great enterprise AI suite, but Alex would be the best person to explain why it is great for generative AI.
So the idea before, so what Abdul is going to show you after is a bit deeper into the component of the solution. And some of the components are on DataRobot. So we wanted to give you a bit of background of what DataRobot does. And for those that have used DataRobot before, there is also a set of new functionalities that are coming. But essentially, as I said earlier in the presentation, DataRobot is an enterprise AI suite. So one of the key thing about DataRobot is we start with the outcome first, and the platform can help you to reach from that outcome. We can turn your data into meaningful AI application that help you to build, deploy, and manage your AI applications. So following Abdul's example here, when he used the email data, the invoice data to then build an AI application. So what you see on the slide is essentially 3 layers. You have the AI app layer, the AI platform layer, and you have the personal layer on the left. So for the AI apps layer, you can think of it as the front end of your AI. You can leverage DataRobot technology here to quickly create application. You can use the best LLM and framework, and then you can integrate those applications into your end system. So this is what Abdul is going to talk to you a little bit after. For powering those AI applications, you have the AI platform layer. So this is the bottom part of the slide. This is where the heavy lift is happening. What we developed as a technology is a way for you to handle data preparation, testing, model governance, and model deployments. So DataRobot offers you tools to be more efficient, and you can also bring your own tool if you need to combine those into one end-to-end pipeline. And on the left side, collaboration is key. And so we made it simple solution so that if you are more code-based guy, you are more developer, you can leverage your code-based tool. But if you are a bit of no-code or end user, then you can still leverage your technology in a no-code way and track all of the change and track the organization into one place. So that's a quick short of the like how you can build an AI solution. Obviously, if you need more information, we can talk after. And then now Abdul is going to show you how he used DataRobot specifically for his use case. Thank you.
Yeah. Thanks, Alex. Quickly looking at what was the workflow before and after we implemented the solution. So prior to the solution, the workflow looked like this. So companies would send invoice, the customer would make payments to the bank statements. The emails would be email acknowledgements along with the invoices as attachments would be sent over. So the 30% of the transactions that the SQL stored procedures would match would go through, and the rest of the 70% would go to manual processing. And these agents would manually allocate and create the transaction records that would go into the accounts receivable app, which would open or increase the balance or line of credit for the company. So the change with our implementation is whatever is left over from the SQL stored procedures, the 70% would go into the platform and use the LLM solution, and the matches would happen, and only the regulated transactions, which even though DataRobot and the AI solution would match them, they still needed to go through manual processing, would go through manual processing, and then so we injected the solution here, and then this new process would take care of that. So solution inputs and outputs, just to understand what the solution would take in as inputs and what will be generated. It would take in emails and invoices from the customers, and then it would take bank ledger as transaction records or SQL table. And then it would take the back office application, which would have the company details, and the solution would then map all of these and create one flat file or one or more flat files for the day. And then each record of the flat file would be kind of like the golden record that would match invoice with the customer transaction or the ledger line item or the payment, and then the company for which that particular payment should be split and sent over. And this output flat file will be fed to the accounts receivable app. Looking at the architecture at a very high level, so you had every day the Azure functions would trigger an data extraction job, which would extract all the transaction ledgers from the bank. It will extract all the application records from the application database. It will then also extract all the emails from the Outlook server, which came in from the customers, and then put them into an Azure blob container and pass. Then another function will just pass the Azure blob container details for DataRobot to pick up, and DataRobot will ingest all those files and use its MLOps framework and the deployment to send data to the Azure OpenAI deployment, which has the GPT-4o model, and get the output from the LLM, and then process it, and then write the golden records back to the Azure blob container. So if we zoom into what is happening inside of DataRobot, what happens is, like, first, DataRobot, we have built-in notebooks and Python scripts to do stability check. Why do we need stability check? Because these are financial automation or financial processes. We need to make sure that the LLMs are stable enough and their output is satisfactory. So we have like a test data set on which we run the LLM. If you have noticed, because these are APIs, the backend OpenAI can over time keep updating these models, so that we sometimes have seen like stability issues as well. So stability checks will intervene and allow us to catch those issues if there is some change in the model, or some update has broken the model. Once we have done the
Abdul
stability,
said, that's quite interesting. So you are saying, because the underlying model might change, you have like tests to ensure the flow will work correctly. Do you do those tests like every day, each time you make the request? How does that work?
Yeah, so every time the process is triggered in the morning. So typically the process is triggered early in the morning because that's when the bank ledgers and all the information is available. So before we start the whole process, we do a stability check because, for example, like couple of months ago, we noticed that tabular data was not really a strong suit for GPT-4o, and suddenly over time, tabular data was being processed very well. So, there were some training that happens I mean, like the examples that they see, they keep on improving the models, or they just add some prompt engineering or system prompt engineering. So those sort of things also is something that we have seen. So that's why we need stability checks just to make sure that everything works.
Okay, very interesting.
Yeah. So once we have the stability check done, we go into text extraction. This is the OCR. So we use Python libraries to or process the PDF files and extract the text from the invoice and also the email. So the emails are stored as JSON structure from Microsoft Outlook. So the Azure functions store them as JSON, and then we process the JSON for the email body, the sender, because sometimes the invoice information is embedded into the email itself and not a PDF. So we provide the complete context to the LLM. So we have uh, OCR for the PDF, but we process JSON and create text that goes into the LLM. So once we have the text, we send the LLM the text using prompt engineering. So an example of the prompt you could see here, it is, we have the system prompt and then followed by the prompt instructions, and then we send the extract of the email and invoice into the LLM. So the LLM comes back with a JSON structure with the company name, the customer name, the invoice number, the total amounts, and the line items. Once we have that, we have our own text similarity matching algorithms and the uh, numeric algorithms for matching, and then that business algorithm runs inside of DataRobot notebook, and then finally we produce the output of the golden records. So while we can't show you the exact implementation because of again data and privacy reasons, we have like a simple demo that will explain what we are doing. So this is another process which is you can think of it as employee reimbursement approval. So payment reconciliation, but for reimbursement flows. So for example, as an employee, I have bills that I want to reimburse. So I just upload the PDF or the photo of the bill. So as you can see, the LLM is able to classify which particular category they should come in, what is the total in the bill, and then I could write some business logic of it exceeding some threshold. So the output, as you can see, is converted from unstructured to a structured format where we have which particular organization this bill belongs to and what was the location, so that we can kind of like use it for our lookups and other stuff. Just a quick example, if we just change it to another bill. So yeah, this is like a petrol bill, so it does all the things. So this is like what we are using. So entity extraction, as you can see here, looking at unstructured text data from a PDF file flowing into an LLM, and it is creating all the entities or extracting all the entities from the system. And all of this is in DataRobot. So even the application is hosted inside DataRobot. So we are using custom applications that DataRobot provides to kind of like show this demo. So what were the key features of DataRobot that helped us build this solution? DataRobot helped us accelerate this development cycle because we used these key features, use cases for collaboration, artifact grouping of artifacts, and allowing role-based access to them. Code spaces, these allow us to provide these provide us environments so that we can run our scripts. The customer didn't have to enable servers with Python servers and dedicated servers to be able to do this. Then we have deployments. This provided the MLOps structure inbuilt so that we didn't have to kind of like build or deploy the model separately and write a bunch of MLOps around that. And then the custom apps where we were able to build service dashboards so that non-technical users could use the system. Net output of all of this, we saw a 120x uplift in processing speeds. So the payment allocation time per email came down from more than 20 minutes to almost 20 seconds. We noticed that GPT models were quite accurate, irrespective of the email structure, the invoice structures, because different companies would use different structures. There would be tables in some, there would be there would be just free-flowing text. The only exceptions to the whole thing is like PDFs which had identity edge encoding, which we understood that we need more Adobe libraries to process them. Watermarks and alternate entities. So those were something that we were able to solve using lookup tables and other things.
You can see
Yeah.
it's a technical presentation, not a sales presentation, because we tell you the result, but we also tell you where we face challenge. So thanks, Abdul. Maybe
Yeah.
before you jump on the best practice, I got a question earlier. I think there is really some interest on the stability test that you made. So I think one question was, is that more manual or more automated? And
Yeah.
then second part of the question is if you can share some insights, a bit more insights on what those tests are.
Yeah. So the stability tests are, we use Python's unit testing framework for that. So you can think of stability tests as just unit tests, but where we give predetermined input and expected output. And what we have written functions or unit tests is to send that predetermined input to the LLM and match the output with the expected output. If the expected output is quite different from what was expected, that means the LLM behavior has changed. So we would be able to stop the process there, go back to debug why the LLM is significantly different from what was the expected, and then make some changes accordingly, either through prompt engineering or going back and looking at support to understand, do we need to change the version of the LLM?
Interesting. So, and then just to clarify, did you test, is it like you test on some email and invoice that you know?
Yeah, yeah,
Okay, so it's like, here's the set that I know the
predetermined. Yeah.
outcome, make sure like this is correct before I move. Okay, interesting. Makes sense.
Yeah, we
Interesting.
just took like a subset of the data that was used for evaluation, and we just made that part of the unit test because we had kind of like the business sign off on what the output should look like.
Okay, interesting.
Yeah. So some of the best practices that we think everyone should follow, define evaluation metrics early. Uh, Evaluation metrics will allow you to kind of like validate the solution. If these evaluation metrics are business metrics, all the better. For example, for our use case, we had the metric match rate, which is kind of like the overall match rate of the solution. And this metric was understood right from the developer to the board member. So this allows you to kind of like validate the solution much better and communicate with every one of the stakeholders. Prefer POC over full build. Like earlier we mentioned, the evaluation metric or the threshold that was set was because of the POC, and we also knew very high level whether LLMs were good zero-shot machines and those were applicable for the solution or not. Version management is crucial because all of these libraries, all of these tools are still, evolving. So sorry for the pun, but the version management is crucial because some little change in LangChain will impact another library or your process or the functions that you have written. So always maintain version management even in libraries as well. Splitting the process into basic building blocks is crucial because we knew that as you can see, we knew that this is an entity extraction and resolution engine that we had to build, but we even split the process into basic blocks where text extraction is OCR. We understood that LLM or entity extraction is process prompt engineering. And then the resolution part is, text similarity. So building it into basic building blocks simplifies your process. Then design forward looking architecture. Your architecture should always take the end goal into picture because there are like data security and privacy concerns. All of these need to be taken into consideration before building the solution, because once you build the solution, you cannot backtrack uh, if the architecture doesn't uh, follow the requirements. Then agentic pipelines can be an overkill. Always think about you don't want to bring a knife to a fist fight. So although they can do a lot of stuff, sometimes you don't want to add the technical debt just because you could solve the process even more simpler.
Conscious of the time, I just wanted to ask you, I was very curious. So you mentioned agentic workflow here was not working well, or it was an overkill. And there is a lot of hype around agentic workflow. Do you mind sharing like your take on where it's a good fit, where it might not be a good fit?
Yeah. So the way we can look at where agentic pipelines are good is the maybe a simple thumb rule that we have followed is if your process requires the LLM to wear different hats at different steps, then agentic processes or agentic pipelines, function calling, all of that works. But if the LLM is being used for one single particular outcome and one expectation, or at just a single step, then you probably can get away with prompt engineering. So in our solution, we could have gone with agentic pipeline, but the only step that we are using the LLM is for entity extraction, even though the
Mm,
customer was also asking for entity resolution through LLM, but we knew that if we used an LLM to match the JSON with millions of records of transactions, that will just blow up the bill. So yeah, so as you can see, in our solution, we just needed the LLM to do one single
mm.
step and one single outcome. We just knew that we didn't need agentic pipelines.
Yeah, I actually had a follow-up question from one of the attendees on, and I think you kind of already answered, but let me ask you still. He's asking why not use the LLM throughout the entire pipeline? Why not in text similarity, or why not in OCR?
Yeah. So exactly for OCR, you don't need to use LLM. Again, it came down to the cost because
Mm-hmm.
cost is also one thing that we had to keep in mind.
Yeah.
So 2000 emails, sending images or PDF files to LLM, that kind of like is a significant cost daily. Then matching, as I said, thousands of records or hundreds of thousands of records when we join it across different tables. That also means like hundreds of thousands of calls to LLM,
Mm.
which again, even though we have long context LLMs, it's just not feasible fiscally in terms of like costs.
Yeah, that makes sense. That makes sense. Sounds like it has to be the last resort using the LLM, and then
Mhm.
you look at cheaper option first. Okay.
Yeah.
Conscious of the time, I know you have like one or two more slides, so I want to make sure
Mhm.
you have enough time.
Yeah. So just to talk about some of the key learnings, always be aware of all the LLM API settings. These can make and break your solution in terms of latency and other stuff. So costs, latency, and all of that. So be on top of all the settings that you have. Write robust exception handling, because output from LLMs is unstructured, no matter what people say or have done. Putting structure onto them is not always guaranteed. So write exception handling as much as possible. You have libraries for everything, so use them. So just explore. You don't have to write a lot of code yourself. There are a lot of libraries to do that, or simplify it. Modularize your flow as much as possible, because you will do a lot of experimentation. So we split our code into different modules so that we were able to run a lot of experiments with respect to the combinations of LLM used, to the combination of Python library to do OCR, to the combination of which similarity algorithms to use. So we were able to run like 15 different combinations and get to the best combination that worked. And then, we have be ready to build a lot of lookups and utilities, because prompt engineering can only do so much. You don't want to, again, for unnecessarily increase the context length, or other cost, or call the LLM multiple times, where you can just simply use lookups to simplify or resolve that issue. Yeah, that's it from my side. I think these are like minor things, but I think we can go into Q&A if there are any questions.
We have 2 minutes left. Again, some housekeeping. So we will share with you the recording of that session as a follow-up email. Opening for any question that you guys have. Otherwise, we will close. Okay. Okay, I think we can close off. No question. Thank you very much. I think very excited to have Abdul sharing. Thank you very much, Abdul, for sharing on your use case. We are actually starting a sequence of webinar. So if you guys have any feedback, if there is any topics you want us to discuss, if you like this format of we bring an expert that tackle a hard problem on generative AI, or if you prefer something else, just let you know. We are always happy to adjust. Thank you very much. Have a nice day, and thanks again, Abdul, for the wonderful presentation.
Thanks, Alex, for having me.